Okay, so now we're picking up with the test 3, which dealt with polynomials. And starting with number 28, we're working on quadratics first, and then we'll get to the general polynomials. And I think you can handle 28 once you see 29. So here, they asked me to find the vertex of this function, okay? And it's in the form, the HK form, which looks like this. Okay, so if I was trying to find the vertex of a function that was in this form, quadratic function in this form, then I need the opposite of 5, but then I need whatever k is. So that's it. The vertex is negative 5, 4. So you just got to get straight that you need the opposite of this part. Think of it like a 0 almost, the opposite of this part, but then you need to just bring that k, whatever the sign is, down. So negative 5, 4. Okay. Now, the reason they want you to do a vertex is vertex of a quadratic can help you to find the answer to a question like this. They wanted to know the domain and range of a quadratic function. Okay. So we can tell from this first term being negative and this being squared that this is going to be a parabola pointing down. So we're looking for that spot right there, the vertex. Okay. And so when it's in this form, what we do is we use that formula, negative b over 2a, and then we find the value of the function at that point, okay? So the opposite of negative 8 over 2 times negative 1, and we simplify that, that's 8 over negative 2, okay? So that would be negative 4, okay? And once we get the negative 4, we're just going to go to the f function, we're going to plug in the negative 4, and you need to be super careful here because of that extra negative. Okay, signs are what kill you. And then watch order of operations. You would square the negative 4 and get a positive 16, but there's a negative out in front of the parentheses. Then the negative times the negative is a positive 32. Then a negative 16 and a positive 32 is 16. And 16, take away the 24, gives us a negative 8. So negative 4, negative 8. And you got to almost picture it to really not mess this up. So that would be that high point, the vertex of that parabola. All right, so when you're asked to do something like domain, you should go and think about this. So domain would be from negative to positive infinity, because that's your x's, right? And this just keeps going not just down, but out. So negative to positive infinity, that's domain. But when they ask you for the range, see how the vertex really was what you needed? The y values go from negative infinity, but then they get as high as negative 8 and then stop. So it'd be from negative infinity to negative 8 with a bracket. Okay. All right, if vertex is important for a question like number 31, I know it has a lot of words, but it's not a hard problem. It gives you an equation. And it asks you to find the how many hot dogs must he sell to earn the most profit. So number of hot dogs for most profit. If you see words like least, most, max, min, you should be thinking vertex. I need the vertex. So I'm going to come in and do negative b over 2 times the a. Okay, negative 68 over negative 2, that's positive 34. And then if I needed the y, I could find it, but this is the x coordinate of the vertex. And, so what I'm looking at is something like this, okay? And I got the number of hot dogs sitting here, and this is going to be the profit in dollars. And I'm trying to find that spot. And so the second you came up with the 34, you really don't need to go further because it just asked for how many hot dogs. So that's what the 34 would represent. So 34 hot dogs. Now, if they had then said, what was the profit? Then you would plug in the 34 to figure that out. Okay. So that was the first part of the chapter, but we didn't do it till after we did polynomials because I like you to know how to graph polynomials before we do that, because I like that the graphing approach on number 32. Okay, on 32, you're doing an inequality, quadratic inequality. Okay, so you're not looking for where does it equal 0, you're looking for where is it less than or equal to 0. But you start out by solving what causes it to be equal to 0. So we factor, set each factor equal to 0, and we get x is either 7 or -3. Okay, so we're looking for what are the solutions, what are the x's that make this true? And you just found that -3 and the 7 are the values that make it equal to 0. Well, you can think about this by superimposing the graph of the parabola on top of that. See this, if I set it equal to y, would be a parabola opening up. This is where it equals 0, and now I'm trying to know whether I need the inside or the outside, okay? And you might have a less than or you might have a greater than, so you have to kind of look at it. Your parabola might open up or open down, so really be careful. So above the x-axis is where y is bigger than 0. On the x-axis is where it's equal to, and below the x-axis is where it's less than. And I want to know where is it below or on. So if I pick any x value in here, that's where my y value is going to dip below the x-axis. And then right here at -3 and 7, it's at 0. So looking at that, I think my answer is just from -3 to 7. And because it was or equal to, I'm going to be using brackets on those. Okay. All right, so if it had been greater than, so if it were greater than, my answer would have been from -infinity to -3, and then from 7 on. It would have been the outside region. It would be out here if it had been greater than. You also can do test values, so you could plug in a 0, plug in a -4, plug in an 8, see which work, and you'd find out for this question, the ones that work are in the middle. Okay, so that's the answer to number 32. All right, I'm getting tired, so I think I'll better stop